Hey guys, I'm here to help you to figure out what's going on for section 3.2, which is proving lines parallel. So yesterday we talked about the fact that we have our corresponding angles postulate, and if two lines are parallel, then corresponding angles are congruent. So in this case we have our two lines and we're saying that they should be parallel, so 1 and 2 are congruent. So today we're going to discuss what the converse of the corresponding angles postulate says. So take a second, pause the video, and let me know what the converse is. So we should say that if corresponding angles are congruent, then the two lines are said to be parallel. So in the box on the first part of your notes, if I'm telling you that the two angles are congruent, then what can we say about those two lines? It should be that they're parallel. So please fill in those two boxes that L is parallel to M. So this is seen as true because it's a postulate, so we know that it's accepted as fact and that that we're probably going to use this in order to help us prove others, because we know that this is something that is not necessarily proven, but it is more so stated as fact. Okay, so for the next few proofs, we're going to be using this particular diagram. This diagram doesn't tell us anything other than the numbered angles. So it doesn't tell us that L is parallel to M. It doesn't tell us that 1 is congruent to 2. That's what we're going to need to figure out. And we're trying to prove that our lines are parallel. So we are going to create a 2-column proof. Oh, I don't want to do that. So we are creating a 2-column proof, and we're starting with our given information. Well, what is our given information? Our given information comes from your initial statement. So it's telling you if 1 is congruent to 2. So angle 1 being congruent to angle 2 is essentially where we're starting. And eventually, the only thing that we know that can prove that these lines are parallel is if we have corresponding angles that are in fact congruent, because then I could use my the converse of the corresponding angles postulate. So we also want to say what other piece of information. Now, I'm trying to prove corresponding angles are congruent. So if I have angle 1, I need to show something with what other angle? Well, your corresponding other angle would be angle 3. Is there any way to link, if I know that 1 and 2 are congruent, is there any way that I can help link angle 3 with either angle 1 or 2? Well, sure, probably angle 2. So step 2 would be that angle 2 is congruent to angle 3. And I want you to fill in the reason for that. Give what that specific reason is. Then based on the above information from steps 1 and 2, we should be able to say, well, if 1 is congruent to 2 and 2 is congruent to 3, then angle 1 is congruent to angle 3. Okay. Isn't that what I needed? I needed the fact that these two corresponding angles are congruent. So step 3, I want you to fill in that reason. Now step 4, well, now that I know that these are in fact congruent, I can say that my lines are parallel because of the converse. So I'm trying to prove that L is parallel to M, and this reason is by the converse of the corresponding angles postulate. If I have corresponding angles that are congruent, then my lines are parallel. So again, I have corresponding angles that are congruent, now my lines are parallel. All right, now based on that last proof, I actually want you to turn the page over. I want you to skip the bottom of the first page proof, so theorem 3.6, and I'd like you to actually do out theorem 3.7. So theorem 3.7 is the converse of the alternate exterior angles theorem, which should be fairly similar to the converse of the alternate interior angle theorem. So please go through and try that now. I'm going to move on to theorem 3.6 in just one moment, but I want you to pause the video and I want you to try filling out the proof for theorem 3.7. Okay, so theorem 3.6, going back to the first page because you should have completed 3.7 by this point, says the converse of the same side interior angles theorem. So if two lines in a transversal form And you should probably be getting this information based off of your given statement. Off to the side it says if angle 2 and angle 4 are supplementary, then blank is parallel to blank. So again, we have lines L and M. They do not tell us that these lines are parallel. We know nothing about them other than the fact that angle 2 and angle 4 are supplementary. So that again is going to be your given information. Angle 2 and angle 4 are supplementary. Okay? So step 2 talks about the fact that, well, all I have for my given is that 2 and 4 are supplementary. So you're probably going to have your next statement be the measure of angle 2 plus the measure of angle 4 is equal to 180 degrees. And the reason for that, you should be able to fill in. Now, again, all we know is that if I have corresponding angles that are congruent, then I have that my lines are parallel. So corresponding angles in this case, if I'm talking about angle 2 and angle 4, right? So angle 2 and angle 4, I can either have angle 4 be corresponding to angle 3, or I could have angle 2 correspond to angle 6. So I would either need to prove that 2 and 6 are the same, or that 4 and 3 are the same. I'm going to start with angles, I'm going to try and prove that angles 4 and 3 are the same. So in order to do that, what's my relation with angle 3? Well, angle 3 and angle 2 form a line, right? We know that those are 180 degrees. So I can say that the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Now, the reason for this can either be your angle addition postulate. It doesn't tell you that they're supplementary, but because they're a straight line, we're also going to include this as part of our given. Because you know that if you have two angles that form a line, they add up to 180 degrees. Instead of the given, if you wanted to write that out, we could say two angles that form a line equals 180 degrees. All right, so now that I have my statements 2 and 3, how do you think that's going to help you? Take a second and figure out what you think you need to do next. So pause the video and try and do that. Now again, we have those two statements. So we have 2 plus 4 equals 180 and 2 plus 3 equals 180. So if you had written this, that would be the next correct step. Figure out what your reason for that would be. From here, you notice that you have an angle 2 plus 4 equals 2 plus 3. Because I have the same angle on both sides, I'm going to subtract them. And my ultimate goal, remember we stated, was that we're trying to get 4 and 3 to be congruent, because then I can use my corresponding angles postulate. So we have that angle 4, well, the measure of angle 4, is equal to the measure of angle 3, and you should be able to fill in that reason for the proof as well. Now I want to say that angle 4 is congruent to angle 3, and you should be able to fill in that reason as well. Now wait a minute, I was able to say that angle 4 is congruent to angle 3. From this point, I can now say that L is parallel to M. That's my ultimate goal, is that I want to say, okay, I showed that angle 2 and angle 4 are supplementary. I did all my work. Because I have the converse of the corresponding angles postulate, I can now say that lines L are parallel to line M. So this here is the converse of the same side interior angles theorem. So if we have same side interior angles that are supplementary, then we know that my lines are parallel. And it stems from the fact that I was able to prove that using the converse of your corresponding angles postulate. So from here, I would like you to flip the page and to complete theorem 3.8 along with the rest of the work. So please make sure that if you have any questions to email me or ask your peers. Have a great day, guys.